Okay, recording. Okay, so yesterday we basically made some more studies about ArcCoSine and its inverse. Okay, so in our discussion, this is the the reason I want you guys to plot these points. I want you guys to have a sense about the graph. Okay, because these two are related. These two are related, right? So when you see this picture, what I wish you to see when you see this picture, right? You understand, right? Let me put this in the middle. Let me put this in the middle between the two. Okay. So let me put this over here, right? That picture, right? We did that picture yesterday by plotting the points and marking the points. And we marked those points. What do we see? Right? That's the question. What do we see? Sometimes a lot of information is in front of us, but we don't necessarily see them. Okay, so we're going to take a second look. We're going to take a second look. I'm going to put this piece on the other side. Okay, so when we see a picture, right? This is too large, 125%. All right, so this includes everything. Okay, so on the one hand, you see the red curve. That is cosine A between 0 to pi. So this is after truncation. So after truncation, if you look at the red piece, okay, we should be able to tell the domain and range. Right? So how do we see that? We see that a box. Do we see that box? The entire red curve is in the box. You guys see that? And this box has a horizontal span, which is how long it is. Okay, horizontal span. That's the horizontal span. And there's also a vertical span. Horizontal span, vertical span. This tells you the domain and range. The horizontal span is a domain and the vertical span is the range. So what is the domain? What is the range? It's all in the picture. Right? So the domain is between 0 to pi, which is indicated here. The range is from where? From -1 to +1. And from the exercise we did, okay, so from the exercise we did, right, we have taken values from 0. Okay, we have taken values from 0 to pi. And the output are ranging from +1 to -1. Do you guys see that?
Mm-hmm.
This box. So this box tells you the domain and range, everything. And we did it in more detail. So you can see the domain is from 0 to pi. Do you see that? The input is from 0 to pi, and the output is from +1 all the way to -1. That's what the picture tells us. Okay, so in a minute, we're going to summarize this. Okay, so now let's look at the inverse, right? We know these two functions are inverse to each other, right? So let's look at the other box. The other box will be the green. Right? So I will draw the green box. The box that boxes the green. This one also has a horizontal span. Okay, the horizontal span. should change the color, right? And vertical span. Horizontal span, vertical span, okay? What's a horizontal span? Horizontal span is a domain and vertical span is the range. Do you guys follow me? So the ArcCosine's domain is the other function's range and vice versa. So the domain is from -1 to +1 and the range from 0 to pi. So this picture tells us, and with all of these examples we did, right? The input is from 1 all the way to -1. The output is from 0 all the way to pi. Okay, so there's a lot of information. If you look at the table left and right, top to bottom, concentrating on input, concentrating on output, and concentrating on the algebraic expression and so on and so forth, and the nature of the function, they're all together in this picture. Okay, so now let's put these together. Okay, and then you get your summary. Right? So these two functions, right? One is called a G. Which one I'm going to call it G? I'm going to call this guy G. Okay, and it's the nature of this function is take an angle to produce ratio. What kind of ratio? Cosine ratio. Okay, and what is inverse? What's the G inverse? What's the G inverse? G inverse, right? And the points we plotted, the points we exercised, they're all about that correspondence, okay? That one-to-oneness. And for the inverse function, which we call ArcCosine or cosine inverse, takes ratio to produce angle. That domain range, right? Their domain range still have that same relationship, right? So what's the domain for G? The domain for G is between 0 to pi, right? And as a result, the range for its inverse will be from 0 to pi. And the domain for the inverse, what is it? What's the range for cosine here? Can someone say something? What's the range for G? We just did the boxes and stuff.
The range is for cosine is -1, and then 1 brackets, and that's also the domain
Right?
for
-1.
G of -x.
And its inverse will have the same thing. Okay, is everybody with me, or some of you just log in and walk away? I know that could happen, but that you really have lost the whole benefit of live lecture, Okay. All right. So with that said and done, what is that noise? What is that noise? Okay. So without further ado, let's look at that, right? So these two functions are what? Inverse to each other. So when we talk about the inverse of cosine, we refer to this truncated cosine, and its inverse, of course, is called ArcCosine. Okay, so these two are inverse to each other. However, cosine function we talk about, which takes any angle to produce a cosine ratio with domain all real numbers, right? With domain all real numbers. that domain is from negative infinity to positive infinity. In most of the time, unless otherwise specified, we are not addressing this function. We're not addressing this function. So most of the time, we're not, let me put it this way. Unless otherwise specified, we are always addressing this function and that function. Unless otherwise specified. Okay, so let's look at the otherwise specified. Okay, so let's look at how we otherwise specify. Okay, so knowing these two functions, right, are inverse to each other, we know that this property also applies. This property applies. Okay, this property applies to any pairs of functions that are inverse to each other. And it certainly applies to G. So how does it apply to G and G inverse? Right? When F is G, so everything is changed to G. Right? So this is going to be G, and this is a G. And for the domain of G inverse, okay, let me get it larger. This software is not consistent. Sometimes it shows the little -1 sign. Sometimes it does not. Even for it doesn't matter. But anyway, so you guys see the sign here, right? So G replaces F because it applies to G in our situation. In particular, right? In particular, in our case, it works for G. The domain, and correspondingly for X in the domain of G inverse, the domain for G, right? So what is G? What is G, right? So if we write the composite this way, G of G inverse, right, of X, and that equals to G inverse of G of X, right? What is G? G is a cosine. What's G inverse? ArcCoSine. You see that? And for this X is in the domain of G inverse. What is the domain of G inverse? What's the domain of G inverse? Right here. The domain of G inverse is that. Do you follow me? For G inverse, this is our cosine. And G is a cosine. And this is true for X in the domain of G. What's the domain of G? 0 to pi. This is how we phrase the otherwise specified. Okay, because this G is still addressing just cosine. When we specify where X is from, we are actually pointing to this function. We're actually pointing to this function. But you don't have to be aware of this function as long as you know just by assuming that you're taking a piece of it. Does everybody follow me? So this is how we do the otherwise specified. If we don't have this specification, for example, right, for the latter statement, okay, for the latter statement, if I remove this, then this statement is what? This statement is wrong. Do you follow me? Because that cosine X, it will refer to, I can remove that parentheses, okay? that x would refer to all real numbers. Do you follow me? Yes?
Mhm.
Refer to cosine. Refer to cosine. When this cosine is referred to, we refer to the domain from all real numbers. If you don't specify that, and that statement is going to be completely wrong. Yes, do you guys get it? Okay, that's the difference. That's the difference between with its specification or without the specification. Okay, we're going to see this from our examples. Oh, sorry, I need to remove that. Okay, my bad. Okay. Another version of this property, okay, another version of this, okay, we'll be using the other notation. We'll be using the other notation. The other notation, of course, is cosine inverse. Okay, so that's the other version. The other version, okay, then this will be cosine inverse. So these forms are used interchangeably, okay? That's because cosine, well, ArcCoSine, okay, let me rewrite this, ArcCoSine, okay? That's because ArcCoSine and cosine inverse are the same thing. And in a lot of the cases, this parentheses is not necessary. This parentheses is not necessary, just for you know, being as clean as possible, okay? Any questions? So now we are ready for some exercise in trick 7A. Okay, are you guys ready? With all the, yes.
I was gonna say, give me a second to like write this down. Sorry.
No problem. Okay, so that's one property. You see this property, these properties, right? We have derived inconsistent with everything we have developed so far with the concept of one-to-one function and the properties of one-to-one function. They are consistent. And they are always consistent. They're always consistent. It's just different functions and different rules. Okay, it's just different functions and different rules. Okay, so with that said and done, we have all of these in our preparation. Now we're ready for trick 7A. Trick 7A. Okay, so let's look at trick 7A. And Jacob, you said you have questions from there?
Mm-hmm.
Okay, so let's start with your question.
Sorry, give me one quick. Okay. Do you think we can do number 18?
Sure. Of course, you guys know that these two properties on the second row of the first table of trick 7A, right? The second row on the first table of trick 7A, right? So you can see that's where it came from. Do I expect you to memorize? That's a lot of memorization. That's a lot of memorization. If you don't understand it, you just bang your head to memorize these. Even if you can memorize it, you will not be able to apply them properly in a lot of the cases, right? That's why it's very important for you guys to study it, to really understand it, to have in your head, you have a picture of all these connections, right? which we have been trying to build that connection. All right, so let's look at 18. Okay, 18, we have a situation of ArcCoSine, okay, and the cosine of negative 3 pi over 4. 3 pi over 4, okay? Whenever we see ArcCoSine, okay, so what's the meaning of, what's the purpose, right? What is the usefulness of knowing the domain and range of all these functions? What's so useful about them, right? So I'm bringing these tables right here, right? What's so useful about you knowing the domain and range of all these functions, right? So first, let me just write it down, some discussions. With the knowledge such as this, right? I see cosine of negative 3 pi over 4. Okay, so on the first inside, okay, I know this guy is going to be between -1 and +1. Before I put the values in, okay, that's the big picture. So I know that this entity, okay, if I assume this entity is a heart, right? So this guy is heart. And I know this heart has to be between -1 to +1 because that's ArcCoSine required the domain to be chosen from, right? So for certain, I know cosine of any real number is between -1 to +1. So I'm referring to this piece. Do you follow me? So if the heart is between -1 to +1, what do I know about the consequence? So what can I tell about the answer? I will know my answer is going to be between what? My answer is going to be between 0 to pi. So before I do the question, because before I actually work out the details, first thing first on your head is in your mind is that your answer is going to be between 0 to pi. Do you follow me?
Mm-hmm.
That's how useful these information are. So for as a teacher, if I grade your work, that's what I see. That's what I see. If you give me an answer outside 0 to pi, you automatically get a 0. I don't have to check further. Do you understand? Surely I can look into details to see if you get partially correct. But that partial correct most likely will be reflected on this step. Does everybody follow me? So there are multiple ways of doing this. So I hope I give you some ideas how your teacher see the question and what tool she uses to judge your work. I'm not judging you, I'm judging your work. You follow me? That's how we use it. And that's the kind of vision we want you to acquire as well. Does that make sense?
Mm-hmm.
So before I see your details, I already expect the answer between 0 to pi. How do I know that? Because I know domain and range. All of these. And this cosine, okay, refer to this cosine. ArcCoSine refer to this guy. This guy is not in the picture, not in the expression, because there's no specification. There's no specification say we're doing there's not even a variable there. It's -3 pi over 4. Okay, so you need to acquire this vision, because when we are doing 7a, we're preparing you to do trig 8. Trig 8, there's no numbers, just variables. So you need to acquire that vision I just specified. I just explained to you. Do you understand?
Mhm.
Okay, thank you. All right, so with that said and done, I'm going to give you a couple ways to, a couple different angles you can look at this. For example, right? If you do this straightforward, okay, if you just do this straightforward, right? Inside you would do ARD, and the outside you're going to do DRA, right? How does that work? I'll show you. Are there shortcuts? There are some kind of shortcut. Okay, so I'm going to show you multiple ways you can do it. But the other perspective, so now we have addressed 2 ways, right? So let's look at if there's a third way. The third way might be, could I use these properties? Could I use these properties I just learned, right? I have an ArcCoSine here, ArcCoSine here, CoSine, right? So the second form is fitting. But the second form require this x has to be between 0 to pi. -3 pi over 4 is not between 0 to pi. So this form does not apply. You can think of it. You can think of it. But just as a note, you don't have to put it down over there. It doesn't apply. You follow me? If you're thinking of using the properties here, it doesn't apply because the x, right, -3 pi over 4 is not in the otherwise specified interval. Do you see that? So this will leave us with only 2 other ways to do it. And maybe there are more, okay? But I just see there are 2 general ways. Okay, one of the ways is you just go straight forward. Okay, so how do I do that? Right, we have ARD. That's our ultimate weapon. I'm sorry, I shouldn't be using the word weapon. It sounds violent. So I'm going to start from the inside. Cosine -3 pi over 4. If you're good at using the unit circle, use unit circle. Okay, you can use a unit circle. If you feel rusty about using the unit circle, just use the general form of the whatever of just the rectangular system. You measure the angle. You measure the angle. So what do I do here? I'm going to measure. Okay, I'm doing ARD again. How many times we've been doing ARD? So many times, right? Why do I do this in front of you? Because I want you to do the same. Okay, and in time you'll be faster. So we have a -3 pi over 4. So this is a clockwise measurement. So I measure this, and so that's a terminal. That's a terminal. Okay, that's a terminal. It's a cosine. Therefore, we know the reference angle. And of course, we also know cosine, it will take the red number. So in this piece, we're going to have -1 over square root of 2. Okay? You guys see that?
Mm-hmm.
And then what? So this piece, we got it, right? Is ARD. So what's the A? A, right? A to what? To D. A to D. That's angle to ratio. That's A to D. Okay? ARD. R is the reference angle. So that's a typical A to R to D. Do you guys see that? That's the ARD I'm into. And next, ArcCoSine. ArcCoSine. When ArcCoSine input is given to us, okay, in terms of ARD, we know the D. We know the D. Right? D, what is D? D here is -1/√2. We know D. Okay, we know D. And what are we trying to find? The output of ArcCoSine give us angle. So we're looking for A. So from D to A. Do you see that? But ArcCoSine has its own specifics, right? That is from the ArcCoSine, we know it takes ratio. Where the ratio is from? The ratio need to be from -1 to +1. What is the range? The range had the output is expected, must be between 0 to pi. So with that said and done, you look at all the negative half, right? From the D to A, all the negative half. How many do we have there? We have negative half, -1/√2, -1/√2. We have two of them, right? From these two, which one will give you the angle which terminates, so that terminates between 0 to pi? Which one? Which one? So you have one here, and you have one there. Which one will produce an angle that fall in the range of ArcCoSine? Where is it?
Would it be
Is it
pi?
this one? Or is it that one? Is it that one? Or is it that one? There's so many choices, right? You can go around and round. But what did we say about ArcCoSine? There's no flight zone, right? There's no flight zone, right? So that no flight zone would shut down what? Would shut down this one. Shut down all of these. So what do we have left? This is the only thing left. You guys see what I meant? So this is the importance of understanding the process we went through, okay? To prepare for this moment, understanding domain and range. You guys follow me? So that's a DRA, okay? So if I put this in that order, right? From D, right, to A. And that angle has to be between 0 to pi. And that angle, of course, is 3 pi over 4. So this is what I meant. ARD, DRA. Do you understand? Do you understand now? So the answer is 3 pi over 4. Okay. So if you don't remember the property, remember the property, whether you do it or not. If you have the basics of ARD, understand the domain and range, understand the basic mechanism of these functions, you can still get it. You can still get it. You can still get it. Okay. But there's another way I do want to show you. There's another way I do want to show you. And you can regard this as maybe somewhat a little shorter cut. Okay. We once talked about that cosine is an even function, isn't it? Is a cosine an even function? We went through lenses to talk about that even function on graph, on table, and so on and so forth, right? So as an even function, what does that mean? Cosine is even. What does the even function imply? Cosine of negative x equals to cosine x, right? Opposite inputs produces the same output. Remember that narrative we have? So in this case, as a result, right? For cosine negative 3 pi over 4, what would that be equal to? A would equals to cosine 3 pi over 4. Okay? So if we use that property, what do we get here? What do we get? We get that. If you get that, this time we can apply this property. This time this property applies. Do you see that? Because same form, 3 pi over 4 is in 0 to pi, in that interval. Therefore, the answer is, oh, sorry. The answer is 3 pi over 4. You follow me? Oops. Sorry about that. Do you guys see that? So this will require a deeper understanding and connecting these properties we have learned. Is everybody with me?
Yes, Professor. I see what you are saying. With memorization, there is no way we can answer this type of question, but by understanding we can. Yes.
By understanding, not only you don't have to memorize a whole lot of things, but you need to have those, understanding of the process, the understanding of the process. That's why we spend so much time on it. Okay, that's why we spend so much time on it, right? So if you haven't listened to the lectures before, you jump in today, yes, you're probably going to be totally lost, right? Because there's no way we can make up for you for, past how long? Weeks of lectures. Yeah, it's impossible. It's impossible. You have to give yourself the gift of time to understand one after the other. I'm going pretty slow already, but these things are so essential. I hope, I think it's worth the time to do it. Okay, it's worth the time to do it, but it's you. I'm just merely give you the sharing of experience. It's totally up to you. You have to do it for you, for yourself. I cannot do it for you. I can only show you. I can only show you. You have to do it, really do it for yourself. But anyway, since we're here, let's try a few other examples, right? Let's try a few other examples. For example, number 4. Number 4. Well, if you guys have any questions in mind, please just bring forward, okay? So we have a cosine, ArcCoSine, sorry. ArcCoSine of -4/5. This might remind you of the questions I once gave you before, right? I once gave you before. That quiz with 32 points, right? With 32 points, right? 3, 4, 5, right? 3, 4, 5 in every quadrant. In some situations, actually in many situations, in the application of your fields, if you ever use trigonometry or these inverse functions, you may not get those special angles. So the special angles are very much for academic convenience. Okay, but those academic convenience is to support ARD, to support the use of ARD. It's not because those angles show up in real life very often. Those angles don't show up in real life very often. So in real life, if you encounter such questions, you have to use ARD, DRA, right? But anyway, without further ado, when you see these questions, right, depending on which angle you come from, if you come from since we just came from getting these properties, you can see the first property applies. The first property applies, isn't it? Does it apply? Yes? That property applies, right? You have a cosine, you have a cosine there, you have ArcCoSine, ArcCoSine, and you have an x here. X is -4/5, and x is between -1 to +1. Therefore, your answer is just -4/5. This is provided that you are clear and understand the process, know this property, and know this property at your fingertips or at your pencil, whatever. But what if you forget? What if you forget? We all forget, right? For example, I forget about these things sometimes. Okay, if I don't teach pre-cal, I teach, stat or other classes for a while. Sometimes I do forget some of these things, like these conditions. I know there's a condition, right? There's an otherwise specification. I know that. But how do I do it? I will go back to the truncation and figure out the truncated piece, and immediately I get a domain and range from there, and boom, I have it right there. Do you guys follow me? So this is what I'm saying. I'm just sharing my own experience. I'm not any genius and teaching you any genius ways. Okay, I learned almost everything the hard way. Okay. If you think my way is too hard, find a professor that's super smart and give you all the shortcuts and you get them right away, and go for it. Go for it. Okay, I just haven't experienced that myself personally. So that's how I get about it. I go about it, right? When I forget, where do I go back to? For cosine, ArcCoSine, right? I will go back to the cosine curve. I found that piece of truncation. Okay, do you know what I'm talking about? Okay, exactly what I have covered with you. When I forget, I go back to my cosine curve. I found this piece. And this red piece has a domain and range, and I know its inverse, which is ArcCoSine, is a reversal of domain and range of the red. And there you go. I got it. So that's usually just take me less than a minute, because I went through that process. Okay, it's not because I have super duper memory. So now in this case, what if I have forgotten? Right? What if I have forgotten? And this is not a special angle either. This is not a special angle either. So then I'm going to show you another way. So these I will call the foolproof way. The foolproof way to do it. Okay. Now, even the unit circle doesn't apply, because the unit circle, those points, those red number, blue number, I cannot find those red number, blue number over there. What do I do? This way I'm about to show you is a fundamental, okay? You might use it, and most likely you're going to use it in your calculus classes, especially calculus 2, okay? So I would resort to definition. So I'm showing you these variety of ways to do it so that you have more in your preparation to deal with any kind of situation. Okay, so with that picture, right, I just start from the beginning. If I, in the worst case scenario, I still know ARD, don't I? And of course, if you forget about ARD, now, we're beyond help. If you don't even know ARD, then you're beyond help. You have to go back to the very beginning to study it, right? So assuming we have the basic knowledge of ARD, and I know I'm dealing with ArcCoSine, okay? I know I'm dealing with ArcCoSine, and I know this ratio is going to be what? This ratio is negative, right? I will know. In this case, let me think out loud. I'm gonna give you some thinking tips. Okay, think out aloud. I haven't used that a lot. If you listen to my past lectures, I use think out loud a lot. But anyway, think out aloud. This is my think out loud. I know this quantity, okay, is going to give me a quantity between 0 to pi. I don't know the exact angle, okay? You might get a approximated angle, but as I said to you, you professors didn't like approximation. They always like precise. So I knew this angle, this is going to be an angle because the output is an angle, right? The output is an angle, right? Remember those basic things I emphasized. ArcCoSine takes what? Takes ratio to produce angle, right? Produces angle. Sorry. Produces angle. Takes ratio, produces angle. So this is the ratio, this is the angle. And where is this angle to be? The angle is going to be between 0 to pi. And the ratio
is about 143 degrees.
I'm sorry?
The angle is about 143 degrees. It is between 0 and pi.
Okay, thank you. But we don't want to deal with that.
Yes.
Okay. The input is from -1 to +1. So these are the two basic things we know. What are where did we see these two basic things? From here, right? We just summarized, right? ArcCoSine domain between -1 to +1 ranging from 0 to pi. That's the application, and we're applying them. And your professor want to see these applications when we are assessing your learning. You guys follow me? Whatever we cover in class, and those are, I will call it bullet points, are the points we will be assessing our student about. We don't need your dry memories about them. We need to see you guys applying them to the real situation. Otherwise, what's the use of math, right? What's the use of math? You see math applied to your cell phones, your computers, and everything, right? For the same token, we want to see that you have these knowledge of applying mathematics. And this is the real case of applying that mathematics, right? The ratio input from -1 to +1. Then you say, what if this is 6/5? Well, that's not in the domain. And this whole thing will be undefined, okay? So thank God this is a negative. We actually have an example of that in trick 7A, you know, it's not in the domain. In that case, it's undefined. Okay, in that case, it's undefined. So when you work these exercises, okay, you want to know what your professor want, right? Sometimes students come to me and say, what do you want? They ask me what I want. I'm telling you what we want. This is what we want. We want you to see these being reflected in your mind. But how do we assess that it is in your mind? I don't know. That's a $1 million question. How do we assess it is in your mind? I certainly cannot be a bug in a student's mind, right? So I will tell you what's going through my mind. A couple of things I check. Is this in domain? Yes. If it is in domain, what to expect? This is what's expected. Okay, that's the algebraic form. So when cosine apply to it, right? When cosine apply to this guy, right? In this case, sometimes we introduce a symbol. We introduce a symbol called theta. Okay, so this will become what? Cosine of that theta. Right? So here from this process, you know your cosine theta is, the theta is between 0 to pi. So before you get the answer, you need to have this big picture, this outline in your mind. But once again, how can we assess that something that's in your mind? From the work you show, we try to have a peek whether you have that in your mind. Whether you have that in your mind. But this is necessary. This is absolutely necessary. Okay, so with that said and done, okay, I will consider that analysis. So I'll start to draw some pictures to show you, all right? We know the output is, well, the input is a ratio. The ratio indeed is in the domain of the said function, ArcCoSine. So the output is a theta. Theta is the angle for cosine of a negative ratio. Negative ratio. Cosine is positive in the first quadrant, negative in the second quadrant. So when I draw the terminal, I will know the terminal is going to be there. It's going to be in the second quadrant. Okay. So from this information, I can tell this is theta. This is my theta. You see, that's A. That's D to A, DRA. Do you guys see that? D is negative 4/5. A is the angle. So I determined that D to A by my knowledge about the domain and range for ArcCoSine. Do you guys follow me? That's on the first, that's on the inside. That's on the inside. This analysis I'm showing you right now is paving the way for our next major exercise, which is trig 8. Is that trig 8 or trig 9? Trig 8. Okay, I want you guys to take a look at trig 8. Trig 8. I'm preparing you for something else is coming. Okay? Don't be satisfied with say, oh, I already know the answer. The quickest way to get the answer. If you don't use ARD or DRA, you're bound to tumble or have hiccups somewhere down the road. I guarantee you. I guarantee you. Okay? Because every question we have for our student is to assess ARD or DRA. Okay? We are very focused on the basics, right? Students often come to us and say, what are you going to test us about? Guess what? Most likely your professor will tell you, we're going to test you the very basic stuff. What is the very basic stuff for trigonometry? ARD, DRA. Okay? All right. So that's theta. You can see the analysis of theta is coming from the awareness of domain and range, and the nature of the input and the nature of the output, which we emphasize all along. But the good news is that for trig function, you either deal with angle or you deal with ratio. You don't have a third category. Only two categories, right? Sometimes the angle is the input and the output is ratio. Sometimes the ratio is the input, the output is angle. That's all, right? That's all. Now, with that said and done, right? Let's look at this piece, this part of the process, right? We have a -4/5. So the point you can get, right? Remember the red point, the blue point, right? The red point, blue point. So quoting definition. So we pick a point on the terminal side of the angle other than the origin. I'm quoting definition. So this point should have a red and blue. So this point should have a red. Okay, should have a red. It should also have a blue. Right, you have a red number, a blue number. The red number is for the X, right? So what's the red number? This is going back to the basic concept. Oh, sorry, that's the wrong color. Okay, the blue. Okay, so let me use the blue. There's a red, and this is the blue. And that's the red. Right? What do we know about these ratios? We know the cosine ratio is -4/5. -4/5. So what will be the easiest way to make that a -4/5? This red is already on the negative side. So this is going to be -4, right? And the 5, I'm going to make 5 here. So you have constructed that triangle. -4/5. If necessary, you can find how high the blue, right? In this case, we don't need it. So now we have figured out what a theta is, right? So DRA. So by this time, we have done DRA just to handle this piece. Okay, so now we know theta. What is a cosine theta? Cosine theta is going to be what? The x/r. We already have the x is -4, the r is 5. Do you guys see that? So that's why the answer, if you go this way, it's also -4/5. Do you follow me? You guys follow me?
Mhm.
Does everybody follow me? So in the worst case scenario, right? You don't know the special angles. You know the basic concept like ARD, DRA, you know, input nature, output nature, and so on and so forth. You can still handle this. You don't have to memorize all those special angles. You really don't need to. All right. So this is the, I'm addressing this because you are going to be using this method in Calc 2. Okay, you're going to be using these methods in Calc 2. Okay, there might be variations of it. Certainly, there are lots of variations. For any algebra question, you have 10 different, you know, you have many different ways to deal with it. Okay. All right. So without further ado, let me just finish, just wrap this up, right? Wrap this up by meaning that the red number here is a -4. The blue number we don't need to know. If you want to know, it's actually 3. Okay, because we're familiar with this triangle, right? 3, 4, 5, right? 3, 4, 5, right? So this is 3, but we don't need to know this. We don't need to know this at this point. In your calculus class, sometime you need to know this, or in our class, sometime you need to know this. So 3, 4, 5 is commonly used. It's commonly used for non-special angle, And the other non-special angle I would say is 5, 12, 13. 5, 12, 13. Okay. So even though sometimes we don't use special angles, we want to test your knowledge about the basic concept, ARD, DRA. we still give you as neat numbers as possible, as neat numbers as possible. Okay, so without further ado, let's move forward. To see whether you guys got this, I want you guys to try your hands on. So we're gonna have a breakout rooms. Do you guys want to have breakout rooms? I'm going to select some questions for you. Are you guys ready? I'm going to select the cosine. I'm going to select question for you, which is number 11. Okay. Number 11. Number 14. Number 11, number 14. Number 20, 22. Number 20, 20, 22, 24, 26. 20, 22, 24, 26. Is that too many? I'm hoping to get started, give you an introduction to ArcCoSine today to see if we can do it. Okay, this is the 6 questions. 2 minutes per question. 2 minutes per question. I'll give you 12 minutes. Okay, give and take 10 minutes because the first 2 questions are pretty straightforward. Okay, so breakout rooms, I'm going to give you 10 minutes. Self-assigned, open all rooms. Six questions. How's it going? All right, guys, how's it going? Farouz, anybody went to your room?
No, Professor.
That's okay. I think everybody is working hard at their desk.
Yes, here. And then I noticed the question number 20 is very interesting. We can convert it as you are showing it. 7 pi
Okay.
over 6, 5 pi over 6.
There are so many ways to do it. There are really so many ways to do it. If you just dig a little deeper in our study from the basics. So I just show you a couple. Okay. For example, you can see clearly on the unit circle, if you have the unit circle, or you know the properties of cosine, which is, on both second quadrant, third quadrant, they're both negative. First quadrant, fourth quadrant, they're both positive, right? You can utilize that property to gain, that's what I use here, right? Cosine 7 pi over 6 and the cosine 5 pi over 6, they're the same value because they share the same, they share the same side of the triangle, right? So let me bring you that unit circle. If that unit circle is what you feel comfortable to work with, go for it. Okay, otherwise you can just use the general form, right? The reason we see this is that when you work with, there's so many different ways to get to Rome, right? So this angle is 7 pi over, is it 7 pi over 4, 7 pi over 6, right? And there's another terminal which is 5 pi over 6, right? So if you see that triangle, this big triangle is a unilateral triangle. If you see the small one, there's a small triangle, two small triangles, right triangles. They share the same side, and that same side is what? That same side is cosine. So that's why we claim that cosine 7 pi over 6 is the same as cosine 5 pi over 6. And with cosine 5 pi over 6, and we can apply this property, we get 5 pi over 6. You don't even have to know the special values. You don't even have to know the special values. You guys see that?
Mm-hmm.
Okay. Then certainly this is not the only way to do it. And you can also go about just go straightforward, just do the ratio, right? You get a negative root 3 over 2. And then, you know your answer has to be between 0 to pi. Therefore, you get the terminal 5 pi over 6. So there's more than one way to get it, right? And so I'm not going to repeat what you would do with the general coordinates, provided that you don't know the special angle, okay? I know some of you probably have never taken trigonometry, so this unit circle might be a little rusty for you, or like a little strange for you. In that case, you just go with definition. Just go with definition. So with either one, you can do it. You can do it. But you just have to, you need to know, you need to spend a lot of time. You need to spend a lot of time, really understand this, okay? Really cultivate this. The next one is that cosine 7 pi over 4, okay? I chose this question because this question, if you look at 7 pi over 4, it's a terminal, its terminal terminates in the fourth quadrant. Okay, in the fourth quadrant, let me use the green still, right? It terminates in the fourth quadrant. Cosine 7 pi over 4. That's a terminal, right? So you can go straight forward, right? You can go straight forward, ArcCoSine, and 7 pi over 4, that's going to be 1 over root 2, positive. Okay, and your angle coming out of ArcCoSine need to be between 0 to pi. 0 to pi. What is that angle with the same red number? With the same red number, right? Root 2, 1 over root 2, 1 over root 2. So which terminal is fitting for that? Because for ArcCoSine quadrant, any angle ended in quadrant 3 and quadrant 4 are non-flight zone, no flight zone. Therefore, your answer is going to be what? Is it going to be pi over 4? Okay, so that's one way to do it. That's one way to do it. Another way to express the same idea, the other way to express the same idea is to recognize that 7 pi over 4, right? 7 pi over 4. You get 7 pi over 4 like this, right? And you also have another piece, pi over 4. These two triangles, right? These two triangles are identical. These two triangles are identical. And the cosine is the shared value. It's a shared value is a cosine. Okay. So in that case, what you can write algebraically to express your understanding in that regard, you can write ArcCoSine 7 pi over 4 is the same as a cosine pi over 4. So when you express it this way, the reader will understand that that's what you intended. That's what you saw. Okay. Of course, we don't know exactly what's in your mind, but it's just a rough assessment. And in this case, that property applies so that you're going to get pi over 4. You can get pi over 4. Okay. So knowing that ARD, do you see that ARD is so important? Do you guys see that ARD is so important?
Mm-hmm.
Very, right? And there well to be other ways to do it. Okay. So let's get over the other two. Right? And for this one, I would just use the even function. So cosine 5, that's going to be cosine 5 pi over 6. You don't need more explanation. You don't need more explanation. Oops. Okay, when your teacher read from the step 1 to step 2, when your teacher read from here to there, and he or she knows what you're using. It's an even function. You don't even need to explain. Okay? Well, just make sure you write the algebraic correctly. Okay? So then that special property applies. Which special property? Which special property applies? Huh? What special property applies? This one, right? Yes? Yeah? That property applies, right? So it's 5 pi over 6. You see that? On the last one, I could use the even function, odd function property. I could, but look at this. Okay, look at this. Suppose I have that ARD in my mind. Of course, you must. Right? I measure this angle. It's a clockwise measurement, right? I ended up here. The reference angle is pi over 6, right? And this terminal is shared by two angles. One is negative 7 pi over 6 and the other angle. So if you understand angle measurement, right? So this is the given angle, right? It's negative 7 pi over 4, over 6, right? And there's another angle, which is share the same terminal, that's 5 pi over 6, right? They share the same cosine. They share the same cosine, right? If you draw that triangle, you share, they share the same cosine, which is the red, right? The red number. Right? However you measure it, the x, they share the same thing, right? Because they have the same reference angle and so on and so forth, right? And now you can, with that understanding, you can do cosine, arc cosine, right? The inside, you will write a cosine 5 pi over 6. And that equals to 5 pi over 6. Which is the same as what we did, right? So the same thing applies. Do you guys see that? Okay, but in the whole process, you know what you're getting. Okay, I'm going to repeat this one more time. Even though I get into the steps, right? But when I see this, right? When I see these questions, when I see, say 24, 26, right? 24, 26, I know the answer should be between 0 to pi. If someone give me the answer outside 0, I don't need to look at the details. Do you follow me? Why? Because I know the range of arc cosine. If you give me an answer outside the range, you automatically are getting 0. I look into your details because I try to take some points out of your partial credit, maybe partial correctness, and that's about all. So you see the power of the knowledge of knowing the domain and range of these functions, which we have spent so much time to visualize, to algebraically express by plotting the points and seeing the pictures and so on and so forth. These are the values for doing these detailed study. And you're going to study in the same manner. You're going to study in the same manner for your calculus concept in your calculus classes. Okay? Because in your calculus classes, calculus 1, there's only just 4 basic concepts: limit, continuity, differentiability, integration. 4 concepts. Your focus should be on those 4 concepts. Every question about that 4 concepts. And of course, there are a bunch of other things, right? I summarize for my student over 130 flashcards. Okay, so in this semester, how many flashcards have you collected? 6 principles, right? Function, one-to-one function, increasing function, decreasing function, even function, odd function, that's 11. Truth table, 2 truth tables, 13. 13 principles. How many rules? 22 rules. Right? 13 plus 22, what do you get? 13 plus 22. 13 plus 22. 35. Right? 35. How many? That's about pretty much, that's 35 flashcards you need. Minimum, of course, if you put the summaries, that's a different issue. Right? But those summaries go with the 22 rules, right? The 22 rules, I mean the 22 rules in basic 1. In calculus, how many flashcards do you need? On top of these, you have about 100 more. How do you remember 100 more without understanding? That would be a mystery. Anybody can do that? That person is a genius. I mean, you can do it without understanding. Just do it. Let me tell you, it's impossible. So you have to work for the understanding. Okay. So without further ado, do you have any other questions? Tomorrow, which is Thursday. Oh my God, Thursday. We're going to be working on arctangent. Okay. And wrap up all 22 functions. Arc cotangent is just, we're just going to mention it briefly. Okay. Next week is week number 8. Week number 8, I will not be giving you a quiz. You'll be given the midterm exam. Okay. You will have Friday, Saturday, Sunday, 3 days to complete the midterm. Okay. And before that Friday, you are going to be told what will be covered on the midterm exam. Okay, so next week we'll continue cover whatever we have to cover, because we have so much more to cover. Okay, we have covered I think the most essential part of this course on exponential logarithm, the basic functions, trig functions, the inverse functions, and so on and so forth. So we have covered the big trunk of the essential concept. We still have the if statement. Remember, we talked about there are only two kinds of statement in mathematics, right? Statement and if statement. Okay, so more information will be coming forward. Just stay tuned. I will see you guys tomorrow. Okay.
Thank you, Professor.
Thank you, guys.
Professor, I have one quick question, or I have two questions.
Sure. Go ahead. What is it?
Okay, so for my first question, I just want to make sure for cosine of x, right? There's like multiple ways to write in the domain, right? And so I want to make sure like the domains I have are correct. So for the first one, it should be 0 and then pi, but with brackets, right?
Which one you're talking about?
Cosine of a.
Cosine of A. Okay.
And the other one should be 0 greater than less than.
Which one cosine of A? You're talking about this one? You're talking about this one?
I'm talking about 0 pi for the domain.
0 pi, domain, range, yes.
And can you also write down 0 is greater than less than cosine of a is also greater than less than of pi? Is that also a domain, or is it the range?
Yeah, this is domain. This is domain.
Okay.
Domain, you look at domains is to express the input. Range is to express the output.
Mhm.
Okay, there are these algebraic forms. Okay, these algebraic forms such as -1. You guys have seen this before, right?
I just want to make sure, that's why, because like at first I want to see if I can do it for
It's just
myself
make
and then
sure.
ask you
Yes,
later.
you're bound to be tested, because these algebraic forms are super important. A lot of our students don't know them and don't know how to use them. For ArcCoSine, there are other forms to express it. All right. And also, this is about the input, the different ways to express the input. Thank you for asking this, right? So I can put this in for you.
Mhm.
And ArcCoSine is between 0 and pi. So these are the inequality way of expressing them. Okay. The domain for this cosine is that, and the range are the same.
Another quick question I have is, are you going to give us a study guide for the final, or?
What kind of study guide can I give you?
That's true. Okay, I see. I guess for my last question is, when I was looking at quiz 15, I saw that it was only 1 to 10, but no time limit. Is that is that correct?
Quiz 15, what happened?
No, I just saw that it's only 1 attempt, but you have unlimited time. Did you mean to do it like that?
Did I say unlimited time?
Yeah.
No.
I'm okay with unlimited time. Like I'll take it. I'm not saying it's bad. I'll take unlimited time for it.
There should be a limited time. Thank you for telling me. Let me see. It might be an oversight. 15.
Oh, I'm sorry.
Thank you for telling me. Let me see if I can still make adjustment. If I can, I will. Yeah, and I have no time limit. I'm sorry.
I'll take not having a time limit, to be honest. I mean, that doesn't bother me. I'll take it. So
I know, but you don't need that much time. I'm good. I'm giving you 20 minutes. Okay. That's my bad. Thank you for telling me that though.
I'll see you tomorrow. Have a nice day.
I'll see you tomorrow anytime. Thank you for your questions.